Hello everyone, this is activity 5 in EMC 221. So here we have light and color theory in 3D environments. So what is light and color theory in 3D environments? So light and color theory are crucial for creating realistic and visually appealing 3D environments. Understanding these concepts helps in simulating how light interacts with objects and how colors are perceived by the human eye. Here's an overview of how color theory are applied in 3D environments. So here we have So this is an example of a point light. So it emits light uniformly in all directions from a single point. For example, a light bulb. So here you can see that the light source is on the right side. So the other examples are directional light. So directional light emits spiral rays of light in a specific direction, simulating distant light sources like the sun. And for example, sunlight. So next one is the spotlight. Emits a cone of light in a specific direction with intensity fading upwards from the center. For example, the example is stage spotlight. Next one is area light. So this area light emits light from a defined area or surface, producing softer shadows and more realistic illumination. For example, a window or a TV screen. Next one is ambient light. Provides base level of illumination, simulating light scattered in all directions. For example, is indirect light in a room. So next one is shading models for realistic textures and shadows. So what is shading models for realistic textures and shadows? So shading models are essential for creating realistic textures and shadows in 3D environments. They determine how light interacts with surfaces to produce effects such as brightness, color, texture, and shadows. So this is an example of a shading model. So other examples are Phong shading model. So what is Phong shading model? It is one of the earliest and most common shading models. Phong shading interpolates surfaces, normals, and circulates light intensity for each pixel. Next one, Blin Phong shading model. So what is Blin Phong shading model? This is an improvement version of the Phong model. The Blin Phong model uses a half-wave vector for calculating specular highlights, which is more efficient and produces softer highlights. Next one is Gouraud shading. Gouraud shading is a vertex-based shading model that computes lighting at the vertices and then interpolates these values across the surface of the polygon. Next one, Lambertian shading. So this is a simple model that assumes a perfectly diffuse surface where light is scattered uniformly in all directions. Next one, Cook-Torrance shading model. So this is a physically based shading model that accounts for microfacet surfaces, providing realistic reflections. Next one, lighting techniques, points lights and spotlights. So lighting techniques are essential for creating realistic and visually engaging 3D environments. These techniques simulate the way light interacts with surfaces, contributing to the overall atmosphere, mood, and realism of a scene. So here is an example of a spotlight lighting technique. So we have many more lighting techniques. So an example of that is ambient lighting. Provides a uniform light that affects all objects equally, simulating indirect lighting. Next one is directional lighting. Emits light in a specific direction with parallel rays to sunlight. That is similar to sunlight. Point lighting. This is a point lighting example. Emits light from a single point in all directions, similar to a light bulb. This is spotlight. Emits light in a cone shape with a defined direction and spread angle. Next one is area lighting. Emits light from a defined area or surface, producing softer shadows.